Okay, hopefully you have copied down this assignment as instructed. If you haven't, pause the video or stop the video and go do that so that you can be filling in the notes as we go along. So this is part 2 of angles and arcs, and we're going to talk about a different kind of angle today called inscribed angles. We already talked about an inscribed circle. That was a circle inside of a shape. So an inscribed angle is an angle inside of a circle. So let's draw a circle. And here's the center of that circle. And let's say we put the vertex of an angle on the circle. So something like this. That is an inscribed angle. Okay, so an inscribed angle has the vertex on the circle, as opposed to a central angle where the vertex is at the center of the circle. Now the inscribed angle has its vertex on the circle. So I'm going to call this angle ABC, and that is the inscribed angle. Of course, this angle also has an intercepted arc. So we can still think about it like pizza, but let's say I'm crazy cutting my pizza this time. So I get this crazy slice of pizza right here. This is my crazy slice of pizza. I can still identify the crust that is going to come with this slice of pizza. It's going to be this crust right here from A to C. So arc AC is the intercepted arc. Okay, now it turns out there is a relationship between the intercepted arcs measure and the inscribed angles measure, and we're going to take a look at that in GeoGebra now. So I've drawn a circle, and this is circle A, the center is A. I also put a central angle in the picture, angle CAD is the central angle. Oh, that's a B, sorry. That's the central angle. And then angle CED is the inscribed angle. What you should notice about these two angles is that they're intercepting the exact same arc. They are both intercepting this arc right here. So the intercepted arc for both of those would be arc CD. That is the intercepted arc. Okay, I'm going to go ahead and measure the central angle first. So I'll use the measurement tool. And that measurement is 109.4, which if you remember, that means that the measure, that means that the measure of arc CD is also 109.4, if you recall, because the central angle measure and the intercepted arcs measure are the same. All right, now let's compare those measures to the measure of the intercepted arc. Of the inscribed angle. So I'm going to measure angle CED, and you'll notice that I get 54.7. Well, that is definitely a significant value compared to 109.4. I don't know if you have noticed what that relationship is just quite yet, but if we take 109.4 and cut it in half, we get 54.7. Sorry, I forgot my decimal place. 109.4 divided by 2, we get 54.7. So the inscribed angle is half of the central angle's measure, or the intercepted arc's measure. Another way of saying that is if you take the inscribed angle, 54.7, and multiply by 2, you should get the central angle, or the intercepted arc's measure. All right, so let's go ahead and write this relationship down. So I'll draw an intercepted arc and an inscribed angle here. We'll call it ABC again, I guess. Alright, so angle ABC is the inscribed angle, and that makes AC the intercepted arc. So the measure of arc AC is equal to 2 times the measure of angle ABC. If I put that in words, the intercepted arc is equal to 2 times the inscribed angle. You can say that the other way around, where you talk about the angle measurement first. So the measure of angle ABC is equal to half the measure of the intercepted arc, AC. If I put that in words, the inscribed angle is equal to half the intercepted arc. Now just note and remember that arc measure, the intercepted arc, is equal to the central angle measure. So that means by substitution in these formulas, I could put central angle measure right here, or central angle measure right here. So remember that the intercepted arcs measure and the central angle measure, we often switch out for each other. Okay, let's just look at the first two examples. Is this an inscribed angle? And the answer to that is yes, the vertex is on the circle. So here's the inscribed angle. So if this is my crazy cut slice of pizza. All right, the inscribed angle is angle ACB, and that means the intercepted arc then would be right here. This would be the crust that would come off with that crazy slice of pizza. So AB is the intercepted arc. Let's look at number 4. Number 4 is no, that is not an inscribed angle. Look where the vertex of the angle is. The vertex of the angle is at the center. Oh, I just realized I spelled central wrong, sorry. The vertex is at the center of that circle, so that would be a central angle. Okay, in the next video, we're going to look at the using this relationship with measurements.